Hello? Hi. Good afternoon, ladies and gentlemen, and welcome back to the third session and last part of our discussion today. My name is Marianna Petrosillo, and I'm the proud project manager of the South African program at the Rest for Africa Foundation. And I'll be your moderator for this last session. I hope you had the opportunity to enjoy food and to enjoy the networking opportunity with colleagues. If not, no worries, because we'll close the conference, the discussion today with a good networking cocktail, and we'll have also wine then, so it will be perfect. And yeah, going now to this session. The title of the session is Maximizing the Potential of Available Connection Capacity. So we heard a lot about the limitation related to grid constraints, the physical limitation for new capacity to be added. But now we'll have the opportunity to enter into more details, thanks to the very informative session and thanks to the contribution of the two speakers that will follow me, specifically coming from, both of them, they are coming from research and knowledge entities, and respectively we'll have the University of Pretoria, who has a strong tradition in engineering and graduates 1 in 4 engineers in South Africa. And the CESI, that is one of our key members at Rest for Africa Foundation, and the world-leading technical consulting company for the electric power sector. So their keynote speeches will highlight the current available opportunities in terms of technologies, but also in terms of approach to make the most of national network. As underlined from our Secretary General in his welcome today, Rest for Africa is focusing a lot in terms of grids, networking, and specifically trying to help the cooperation between the private and public sector. And now, today, we are hearing from Fabio Riva from CESI about the the key outcomes of the reports, of the latest technical reports that Rest for Africa developed in cooperation with CESI and also with ESCOM, in order to support grid planning opportunities for renewable energy projects for the next decade in South Africa. But before that, I wish to invite Professor Raj Naidu on stage for his insights on global trends to accelerate energy security. Professor Raj Naidu is head of Department Electrical, Electronic and Computer Engineering at University of Pretoria. Within the same department, he also leads the smart grid research, being at the forefront of cutting-edge research in the field. In his 25 years of experience, he has held numerous leadership roles, bringing significant contributions to the development of power and energy systems, as well as emerging area where the power grid meets IoT. So, Professor, over to you. Thank you.
So thank you very much, Mariana, and it's a pleasure to be here, and good afternoon to you all. So I'm going to look at some global trends to accelerate energy security. We've talked a lot this morning, and I think it's a lot of doom and gloom, looking at load shedding and all the problems that we have in South Africa. So hopefully I can give you a glimpse of why I think that we can solve these challenges, and it will be solved in the medium, hopefully short term, but realistically medium to long term. So if you look at my presentation, will cover the current landscape and drivers, just very briefly to understand what got us here and what the key problems are and the key drivers. And then we're going to look at the global trends, looking at digitalization and the impacts, decarbonization, electrification, and energy storage. So if you look at the industry, I mean, if you look at South Africa, you know, we've got an aging infrastructure. So if you look at the power stations, a lot of them should have been decommissioned a while back ago, but they're not. So they're still operating, but at reduced efficiency. So that's a huge problem. And so we're getting a lot of outages from our power stations, but we can't really do much but to limp ahead. We've got, you know, from a customer perspective, we've got transparency and accuracy issues. Customers are not happy with the utility bills. They're not happy with load shedding. So from a customer satisfaction point of view, it's very low. And then there's climate change, which is another key driver for us. And if you look at the bottom, and if, you know, I don't think we've done this research, this might be a nice research topic, but looking at, well, how does, you know, if you link factors to the inconvenience that's experienced by customers, what would that be? Now, just chatting to people in industry, if these factors change, and you can see it should be proportional to the level of load shedding. You know, the higher the level of load shedding, the bigger the inconvenience to customers. You know, I mean, we experience it on a daily basis. But essentially, that can create instability in the country as a whole. So we don't want it to get to a stage where it's at such a level where it starts creating instability in the country. So that's the end of load shedding and the problems. Let's see what can be done. So I'm going to deep dive into some of the trends. We've done a lot of research into what's happening internationally, what's happening locally, and you know, how we can accelerate and solve some of the challenges. Now, if you look at the industrial revolutions, there's been a lot of revolutions in the past. You know, we had Industrial Revolution 1.0, there was mechanization, steam power. Industrial Revolution 2.0, that's where we had the assembly line. 3.0, we had computers just taking off, you know, Microsoft, Apple, computing becoming mainstream. And then today we've got Industrial Revolution 4.0, and the president has announced many times in the SONA, you know, the impact of 4IR and the technologies. But I think, you know, if you look at the difference between other revolutions, if you look at Industrial Revolution 4.0, there's three key things that it combines to create sort of a perfect storm. You've got the Internet of Things and sensor technology. You've got cloud computing and artificial intelligence. So if you combine those three, it creates sort of a perfect storm for getting things done a lot quicker than previously. Now, if you look at the slide, that picture on the right here, now, if we look 20 years back, and you know, just when cell phones started, and if we were thinking about, well, let's progress 20 years from now, and where would we be? You know, everyone was probably thinking we're just going to have a smarter or a much better Nokia phone. Nobody thought that we would have smartphones, that the world would change in the way that it has. I mean, fast forward now, it has, you know, increased exponentially, you know, to a point where we wouldn't have expected it if someone told us 20 years ago that this is where we would be with smartphones, the App Store, and the world being the way it is. So I think pretty much in the same way, if you look at the energy space, or if you look at just, you know, industry in general, if you look at Silicon Valley and what's happening there, there's a lot of industries that have been disrupted quite significantly. If you look at Uber and how it's radically transforming, you know, the taxi industry, Airbnb, how it's transformed the hotel industry. In a similar way, we haven't experienced that level of disruption in the power industry. It's been much slower to disrupt, but it doesn't mean that it's not getting there. And I think that's really where we're heading in the future. So if you look at traditionally, you've got conventional energy sources. You know, in South Africa, we've got Mpumalanga. That's where the bulk of our power stations are, and then power is distributed to different locations around the country. So one of the future emerging technologies that we're going to see is looking at virtual power plants. So traditional power plants, it's connected to physical resources. A virtual power plant, it uses the entire digital infrastructure to connect your end user consumption, power storage, your conventional energy sources, and your renewable energy sources. Now, I've heard very convincing arguments around renewable energy, and I fully agree with it. I mean, that's really the future. That's where we're heading, and hopefully we get to a future where renewable is our primary source of energy and conventional energy source is our backup power that we need. And so what virtual power plant does is it connects all of these different resources into one virtual power plant. And just using cloud computing, edge computing, it's then able to connect all of those and operate everything efficiently. Now, if you look at renewable energy resources on its own, it can be intermittent. If you've got solar PV in your home, you would know on a cloudy day, you're not going to get as much power out. So I think in order to balance that off, if you've got adequate storage, then that compensates for the intermittency on renewables. Right, so the other emerging technologies that you find would be hydrogen fuel cells. We've got electric vehicles. So with electric vehicles, that can be your backup power storage in your home or your business. If it's looking at the future, the battery storage that you have there is essentially equivalent to the battery that you've got, your lithium ion, if you've got it in your home. So all of these can combine very nicely in order to mitigate any risks. And I like the definition that I've heard this morning about energy, on energy security. That is to, deliver uninterruptible power at an affordable cost. That's exactly what we should be doing. And I think that's where VPPs can play a significant role in the future. So from a demand response point of view, there's, it's already implemented around the world. It's working. Energy storage, large-scale energy storage has been implemented. If you look at conventional energy sources, and if you look at Kusile and Madupi, it's cost it's 300 million over budget, and it started in 2008, and it's still not complete as yet. So it sort of gives you an idea of the scale of the challenges we've got in implementing conventional power stations. So it just makes sense to go renewable energy, but balancing it off with power storage as well as demand control. That's really the future. The other key area that we're going to see huge growth on is on looking at smarter asset management. So if you look at asset management as we have it now, most of it is reactive in the sense that you fix it when it's broken. So when a power station is down, someone would go out there and fix it. Planned maintenance, in some cases, there are scheduled planned maintenance. And over many years, there's been a lot of looking at, the Japanese have done this very well. That means, looking at defect elimination to improve performance. And that's proactive. And if you look at the bottom, that's your original equipment effectiveness. So if you're fixing when it's broken, you're not sweating your assets. So you're actually losing money if you look at your life cycle cost of the assets. But where we want to get to is digital twins. That's where you can be predictive. Before failure happens, you would know. Before the machine starts smoking, you would know that there's a problem coming up. So we, using IoT, using intelligence, artificial intelligence, and using sensor technology, you can get to digital twins. And a lot of it has been implemented. Some of it expensive. If you look at your 9-gas transformer condition monitoring, it can be fairly expensive. But I think, again, it's a volumes game. If there's more volume of the of smart sensor technology being deployed, then it will become a lot cheaper and more competition, of course. So decarbonization, climate change is here. I don't have to talk about it. Everyone feels it. You see it in the news. It's a reality for all of us. And I think the huge drive for carbon, to implementing carbon taxes, and South Africa has to comply with that. So it means that in order for us to ensure that, that we can export product, we've got to ensure that we decarbonize in line with global trends. But I think we've also heard from Salvatore that it makes sense. You create jobs, and there's a whole lot of other spin-offs for renewable energy. Now, the other trend that we're seeing is electrification. There's some areas that we're never going to get to with Eskom, and it's just a fact. It doesn't make business sense for Eskom to reach certain rural areas. But I think if you look, this is just an aerial view on Google Maps on an informal settlement in Gauteng. And if you look closer, you'll find that there's PV panels there. And I think there was one of the audience members that talked about them implementing microgrids in rural areas. So it will happen, but I don't necessarily see Eskom making that happen. It will happen probably by the private sector, but obviously, government should be encouraging that and providing incentives where needed. But the communities are not afraid to take matters into their own hands. So if you've got a few panels, and all that is doing is it's powering your DSTV dish, or it's charging a little bit of batteries, and you can charge your cell phones, and you have some lighting, then it makes sense. And it will scale up organically on its own. So here's the big problem for municipalities and for Eskom that we see. So traditionally, very simply, Eskom has your energy charge, your demand charge, and then there's some operational costs that you would have. And they would resell to municipalities, and there would be a slight surplus traditionally and a profit. But what's happening now in recent years is you've got non-technical losses increasing, so that means electricity theft going up, and even Monde spoke about, when people do go off-grid, I'm talking about residential and commercial, those that go off-grid would be the ones that can afford it and are paying for the electricity account. So the rest of the people that are probably going to be left on the grid are, you're going to look at residents that are non-paying, and what's going to happen is your losses are going to increase even further. So your paying customers are going away. Your losses are non-technical losses are increasing. Your technical losses will also increase if you don't maintain your grid and you don't have enough funds. So in effect, what's happening is this scenario is emerging, and it's probably going to become, unless there's a radical change of direction, that's going to become much more the everyday reality. And you've all heard of municipalities being bankrupt. I mean, no one's ever spoken about municipalities making a profit after being bankrupt. So yeah, I think that trend is set to continue unless we do something different. The other thing that we're going to find in the future is peer-to-peer energy trading. So now blockchain is not Bitcoin. I know there's a lot of negativity around Bitcoin, and rightly so with a lot of it. But if you look at Bitcoin, the underlying technology that supports Bitcoin is blockchain. And blockchain is a very solid platform, and through its smart contracts, it can facilitate energy transactions very well. So we see, rather than going and connecting up to the municipality, if you've got a closed network, you'd probably have much more energy sharing happening within the community. And we see that taking off and becoming, and with utility power being a backup option. So that's sort of, I'm not going to take up too much of your time, but I think that's sort of, in a nutshell, a glimpse of why I think that it's going to be positive for the future, and the kind of trends that will accelerate the energy transition. Thank you.
Thank you very much, Professor. Indeed, all the trends that you covered are rapidly changing the energy sector landscape in South Africa, but also in the rest of the world. Now, coming to focus more specifically on the South African context, we have Mr. Ronald Maré, Manager of Strategic Grid Planning at Eskom, and Mr. Fabio Riva, Energy Engineer Consultant at CESI. Ronald and Fabio have been working together for months on an analysis on the integration of non-programmable renewable energy in the national electric system of South Africa. So I think, Ronald, if you are ready, you can come here and start with your speech. And then Fabio will follow. Thank you very much.
Thank you. It's really interesting times that we live in with congestion in the grid across most places in the world. We're not unique, and we also experience this congestion. And in order to overcome this, there's a lot of collaboration and partnering that becomes critical. And we really appreciate this partnering with Chezi and with RES for Africa for their contributions in understanding the complexities that we have to deal with over time. So just a word of thanks for their contributions in the work that is done. I don't have many slides because I'd like the focus to be on the work that has been done, but I think this is a very important slide. This slide indicates the available capacity on the grid in the various supply areas shown by the green bars and the red bars. And what it indicates is that the Western Cape and the Eastern Cape are really extremely congested, as we've seen in the last bid window round. But what we see with the gray bars is that this is the interest of cost estimate letters or that are still valid within those particular areas. So the Western Cape in the last round had 1,820 megawatts available capacity. And the interest, if we exclude what was allocated by the budget quotes, was over 18 gigawatts of interest in the area. So you can see the reasons why it rapidly got eaten up the capacity, because of the high quality resources in the area. And this drives the need for the significant grid strengthening that is coming. We see that in the Northern Cape as well, but what I want to draw your attention to is that in the green blocks where they shows there's still capacity across the country, you'll see that the valid cost estimate letters in gray and the ones that were issued this year, which are in yellow, significantly exceed the capacity in the areas. In other words, the pressure for congestion within the remaining areas in the country are significant. It's not just the Western Cape and the Eastern Cape, it's the pressure across the entire grid that becomes important to maximize what we currently have to put in the renewable plant. And of course, the main reason for this is that the renewable plant tends to have about 4 times as much requirement to integrate compared to conventional plant. And in the areas where we have the renewables, there is very limited capacity within of load and capacity on the grid. So there's going to be immense pressure on the grid to be able to integrate the volumes that we see coming in time. What you'll see is in Mpumalanga, the promotion of integration in that area has also indicated a significant increase in interest in that area. But again, it is reaching capacity. So it's really important that the way in which we integrate the renewables into the grid is optimized to maximize our current use as we face the challenges of expanding the network due to constraints in getting servitudes to be able to develop and expand the network. And this just highlights the fact that 80% of the load is in the north of the country in the blue area and only 20% in the south. So only 6 gigawatts is in the south of the country. And we've already integrated to date more than 6 gigawatts of renewables in the area. We've got 2 gigawatts almost of nuclear in the area. We've got gas in the area. So the power rapidly starts reversing and starts feeding into the north. And because historically the networks are designed for the load, this is the reason for the limited capacity within the area. The green at the bottom shows the rapid change in the future of generation that needs to be integrated in the south of the country, where we'll get more than 50% of our generation coming from the south to the north. And therefore, understanding how the various renewables value adds to this mix is really important. And part of the study that Fabio will share with you is to show the value of transmission relative to these resources, and why not only is it important to unlock it, but it also provides a value opportunity for the users of electricity. It is also important to understand how the renewables profiles impact the way the grid is congested. For example, you may have wind with a high capacity that we procure, but if all the wind comes at the same time, it's going to increase congestion. And if all the wind comes at nighttime when there's no load, well, it's not that useful. So it's really important to understand the resource, and this is part of what the study does, is it unpacks the value of the resources relative to the time value that we see and the locational value, which you'll go into more. But in the end, we need to integrate these resources, and we need the network, and we need it to be built. And the sooner we do that, the faster we can resolve the energy security problems in the country. And we are working on this tirelessly. And as I said, the biggest challenge is to remove constraints on the ability to build. But we are collaborating and improving those resources, and this will come. The important bit here, though, is in these supply areas, it's very important to understand how much load is in the areas and how much generation is in the area. And it plays a very important role of how much is in the area and what time that we receive it. Because the sum of these two means that the remaining of that capacity needs to be exported out of these areas. So the less load that you have in the hours that you are generating, the more that generation needs to be exported out of the area. And the pipe that we export has got limited capacity. So being able to balance how much load and how much generation and synchronize them become really important. So the load typically has a profile based on the economics in the area, and the generation can have both wind and solar. And the combination of these time series is actually where congestion results. So having more quality information of the resources and the capabilities helps us better understand and maximize the value of the corridors that we have. Just knowing that there's wind coming or solar coming is not as valuable to maximize the corridors that we have. And when we look at these combinations of congestion on the corridors, and when we combine the wind and solar for export, we see that the wind and solar can have congestion periods for relatively short periods of time. But these congest the grid because failure at that point could be catastrophic and cascading across the grid and result in blackouts, which would not be acceptable. So what we need to look at is, in order to maximize this value, we need to embrace different mechanisms that have value propositions. One of these key value propositions is curtailment. We can increase the renewable penetrations in areas, thereby exceeding the capacity of the grid. But instead of violating the capacity, we curtail that amount of energy that exceeds above for the short periods of time that is causing the constraint of not congesting the grid. This allows us to pack in more renewables into the area and sacrifice in small amounts 10% of the energy, but maximizing significant amounts of decongestion within the grid. This cumulative assessment allows us then to integrate more rapidly in congested areas and allocating renewable resources. And these are further works and research that we are doing to be able to understand the maximum capacity we can integrate within these areas. But it doesn't stop there. When we look at the load within the various areas, the load is very important of when that load is incentivized to come. So for example, in the Northern Cape, we've got lots of solar, and the load might be incentivized with high prices during the day not to use load, and rather to shift the load at night times when it is cheaper. That's the historical nature of the loading. But this makes no sense at the moment, because the congestion is because there's too much generation in the day and too much load. So there are other mechanisms that we can put in place to reduce the load at night and rather incentivize the load to come during the daytime. This way, you naturally get a coincidence of load and generation and the ability to decongest the grid. So there are many more intelligent ways that we can to resolve the energy crisis than just looking at it as a network constraint. These levers and mechanisms need to be explored to maximize the value of what we got, because this is what we're going to be able to reduce the emergence of load shedding in the near period while we're waiting for the transmission to come in. So thank you very much for your attention, and I hope you look forward to the research work that has been done to provide more insights into this work. Thank you very much.
Hello, everybody, and thank you, Ronald and Mariana, for the presentation and support for the work. So my name is Fabio. I am an energy consultant at CESI, and on behalf of my precious team, Silvia and Simone, that are sitting up there, today I would like to drive you towards the main insights and conclusion about the study. So I was asked to give you good news. So I hope to meet your expectations, because actually there may be a lot of good news for your system. So I will start with this quite straightforward starting point that is on the basis of the studies and the collaboration with Rest for Africa and ESCOM. So I'm sure that you already know the massive numbers concerning the energy transition in South Africa. So I will start with the first one. It is expected a huge decommissioning of coal power plant in the South African system to be replaced in terms by an even more massive quantity of electricity from renewable energy resources. And in the meantime, the decision to restructuring ESCOM in order to properly managing this transition. To these 3 points, we should add a new one that Ronald described before my speech, that is there is the need to assess these resources within the current South African power system. So these 4 points together ask and call for a proper management of renewable energy resource integration within the South African power system to enhance these numbers that we can see here. And so the general objective of this study is actually to try to address the integration of this massive amount of renewables within the South African power system. And how to do it, the specific objective of the study is to try to perform an understanding to perform a geospatial analysis to understanding which is the value of the renewables within the territories. Why this? Because, of course, the two animations are pretty straightforward. Renewable energy resources highly depends on the location where you install them. So now let's see together what we mean for the value of the resources. So when we talk about the value of the resources, we talk about mainly 5 aspects. So which is the actual potential of renewables in your system? First, when we talk about value, we talk also about economics, which is the cost of producing electricity within all the South African territory. Third, in terms of value, has exploitability. So we will see together that your countries have a very huge potential. So which are the optimal combinations of renewables in order to reduce the cost of production? Viability. So let's see where to properly install and set the renewable sources that are necessary for your transition. And last but not least, assess which are the implications for the grid standpoints. And why? The reason is to answer one of the most important dilemma that the South African power system is facing, a dilemma that is here assumed in these 2 graphs. So is it better to focus more on installing renewable energy resource far from the grid, but where the resource shows the highest potential, or on the contrary, install renewables close to the load center where the grid is there, but exploiting context and locations with a low renewable energy potentials? So in brief, we try to study to answer to this dilemma and assess which is the opportunity cost to install renewable where the potential is the highest in order to justify and support investments in the grid expansion and reinforcement. who will be the beneficiaries? I think that you can all fit within one of these three categories. So we have, of course, HESCOM, because it is asked to be the grid planner of your system. The power producers, because, of course, the market opportunities comes from a clear transparency and understanding of where renewables really can not only have the lowest cost, but can be injected into the grid and so get remunerated. And finally, the IPP office, because it is the one that is asked to promote renewables in your system. So today I try also to make the things simple and give you the main key message of the study that you can find with all the technical detail in the report on the desk out of this room. And I would like to start by, of course, reporting in brief the methodology that we followed. First, what we did is to create 2 maps displaying the renewable energy resources in terms of potential of your country, both for solar and for wind, to then pass through an analysis of the actual technical potential in terms of energy yield and capacity factor that across all your country, with a quite high resolution, we will see it, can offer to the system, by passing through an aggregated analysis province by province in order to see which are the numbers that characterize the most, I would say, favorable provinces for the different renewable energy resources. Passing through the calculations of the indicators that are used to then identify the optimal allocation within the territory. And when I say indicators, I mean 3 main KPIs. First, the maximization of the power capacity. So location by location, we went through the identification of the highest capacity of resources that can be installed. The energy in terms of production, annual production, location by location, and finally, the cost of electricity. These 3 indicators to go to and optimize, again, location by location, which may be the optimal installation of the different resources. And finally, an assessment of the impact of this massive installation within the existing grid. So this is in brief the methodology. I will not go through all the calculation, of course, and just to give you the main messages. And I start with this quiz, I would say, and I ask you, in your opinion, what does this map may represent? So don't be shy and just, yeah. Okay, yes, yeah, that's correct. So orange is sun and blue is wind. So, and then, so what this map represents? Yeah. Yeah, okay, it's more or less this. I give you an hint on this, what this number represents. I missed on purpose the unit of measurement. So what it may represent? The minutes to close the presentation. No, we have still double it. Yeah, again? No? Yeah. No, it's much, I mean, it's, okay, but yeah. No. It's, I mean, I know because you cannot find the answer because it's quite impressive. So we are talking about the potential of renewable in your countries. The map does not represent the optimal allocation, but it is an optional graph, just to say that if we want to minimize the cost of electricity, we may install more than 4 terawatt of capacity, and with that solar and wind allocation. It's just an optional graph to maximize the cost. And as you can see here, the hint number one is quite straightforward. You have a territory with a superhero of renewable potential. And the reason why we have these, I would say, spots is because we just consider the areas where, based on a 2017 study of the CSR, are the territories where it is feasible to install renewables. So we skipped, we left out all the natural areas, land coverage area, and so forth. So these are the optimal capacity that can potentially be installed in the area where you can actually do it. I'm sure that the first question you may have here on your head is, oh yes, but we all know that it's not economical, it cannot be possible to install of this capacity, because, I mean, the cost is too high for some locations. And so the second message that I would like to pass to you is that not only you have a huge potential, but there is also have a lot of area where you actually can install almost all of that capacity with low cost. In the graph on the left, you can see that if you cover all the admissible areas with just solar, the differences between the least cost areas and the highest cost area is just in the order of 20% of differences. This is not actually so true for the wind, but if you look at to the light blue areas, you can see that in this light blue area, you have a quite very low or low LCOE. And trust me, this low area allows you to install gigawatt of wind, meaning that also for wind and also for solar, there is space for everyone who wants to install low-cost renewable energy resources. Just another information, the dots are have a resolution of 5 × 5 kilometers that we considered for the studies. But there is actually more than that, because if you look at this graph, it represents the areas where you may install both wind or solar. So you can take a decision. And as you can see here, most of this area fall within the gray color. The gray colors mark the areas where the cost of producing electricity between solar or wind actually fall within a range of plus minus 50%, meaning that you should not consider your country, your territory, as divided in good solar spot here, wind solar spot here, and so different. But you have the potential, you have a unique territory where within the same area, you have the availability of both low-cost sun and low-cost wind. And our main hint here is that you should build upon this fact to maximize the integration of the renewables within the same area. And we will see that this is not only good for an energy market perspective because you differentiate the investments share, but also because you decrease the probability to be curtailed. And so this for the developer perspective, but also for the grid operation perspective, this contribute to solve all such problems that Ronald tried to introduce before. And I will try to go this analysis of the problems with a hint number 4, where we try, with the case studies and an exercise, to see at which extent the integration of wind and solar may be beneficial to the grid. Here you have on the right a graph that display for 1 megawatt, a normalized 1 megawatt capacity, the results of production for solar and wind on a daily basis. The orange curve is the production on the 24 hours for solar, for 1 megawatt of solar, and in blue you have the production of wind. This is a typical summer day. And in green, you have the same 1 megawatt of production, but produced by 50% of solar and 50% of wind. And the results is that two main things. First is that you decrease the standard deviation, that is the STD parameters, hour by hour. So basically, you decreases the differences of production with 1 hour, with the others. That is a good point for the operation perspective, because it's easy to dispatch power when you have a smoother production. But also, you, on average, have the same production, but with the lower peaks. It's also good to avoid curtailment. The same for the same day, another day during the winter. So integrating the resources according to a share that, of course, it changes location by location, allows to support and provide benefits for developers and also for the dispatching activities. Keeping the hint number 4 on VRS integration, there is another good result, that is this. In this graph, you have displayed 2 main very, very bad parameters. Bad from the perspective of the generators and bad also from the perspective of the utility that manages the grid. So you have here on this graph the sum of 2 effects that anyone wants to avoid. The gray effect is the unserved load. And you are experiencing here every day the effect of the load shedding. So this is the amount of load that is unserved. And on the red parameters is the overproduction. So basically the production of renewables higher than what the grid can absorb. So we took again a reference 1 megawatt load, and we tested which is the best combination of wind and solar able to minimize the sum of these 2 bad effects. And the result is that the optimal combination of wind and solar to minimize this effect is actually going through 50 and 50% of PV and wind. And if we take the same capacity just supplied by PV or wind alone, we can see that these 2 parameters are not any more optimized. Meaning that if you just think about standalone solar, standalone PV, without having a system, looking at the problem, the system perspective, you actually are going to increase these 2 parameters that are not only good, not only bad for the operators, but also very bad for who produce and sell electricity. So hint number 4 here, that also from a demand-supply balance perspective, the integration is a win-win strategy. Now, let's go back 1 second to the overall objective of this word, so which is, at the end of the day, the cost opportunity for renewables and grid expansion in your system. When we did this exercise, we tried this exercise, we calculated all the optimal capacity considered in your latest integrated resource plan. We tried to take all of this capacity, imagining to install it in the northeast part of the country, where we have seen before you have a higher connection capacity and where the grid is already developed and close to the load center. So what we have seen is that if you install all the capacity there, you have a total cost of electricity for the system that is billions of dollars higher than installing the same quantities of resources in the most promising location. Meaning that installing the renewables where they actually are allow to unlock a quantity of dollars, billions of dollars, that can be then invest, of course, for grid reinforcement. And this comes for free, just because there you have an electricity cost that is lower by the nature of the resources. But again, come back to the premises of this. It was an exercise. So we thought, as a main hypothesis, to be able to put all the resources there. But the reality is that you cannot do that. So if you take the numbers considered in the IRP, there is not enough space in the northeast part of the country to install all such capacity. And this was just the 2019 values. We know, you know, that the latest transmission development plan of ESCOM adds some tens of gigawatts. So this consideration is still more valid considering the numbers of renewables that I described at the beginning. So at the end of the day, you still need capacity expansion to support the integration of all the renewables that from your IRP are considered. So again, at the end of the day, installing, expanding, and reinforcing the grids to be able to host all these renewable is something that sooner or later someone has to do. So, and what's next? The idea is now with the Rest for Africa and ESCOM to try to add another piece of the puzzle and investigate what can be actually done now in order to wait for the grid expansion. And so we are trying to go towards what Ronald was saying about try to optimizing what you already have with these studies that aims at identifying the maximum connection capacity by standing upon the complementarity between the loads and the renewable energy resources for each the supply area. So with these slides, I end my speech. I hope to have met the expectation of giving you good news, because really there are good news for your system. Thank you very much.
Okay. Thank you, Ronald. Thank you, Fabio, for this summary. I think it was very informative, and I encourage all of you that wants to collect more information on the insights and the report to grab a copy of the study, otherwise to go on our website to download the file of the report, so the full report. Okay, so now we have to go straight to discussion, as we have a couple of discussants that needs to leave soon. So I invite onto the stage my panelists, and so I'm gonna call them. Today we have for this discussion Mr. Sekomoko Skepper from the head of transmission of ESCOM. So please, Sekomoko, if you want to join us. Then we have Louise Paulsen, that is Vice President Renewables at Sasol. Then we have Marcelo Castillo Agurto, Head of Business Development at Enel Grids. And finally, we have Mark Denton, Board Member at Sawia and CEO at Red Cap Energy. Thank you. Okay. Yeah, I know that you have to rush. So yes, as we heard, the landscape in South Africa has been changed a lot because of the measures that have been introduced, but also because of the booming of the CNI market. So we want to discuss now which kind of, how the CNI market contributes in terms of electricity for the country, but also which are the changes that this kind of new landscape brought to the South African electricity system. So I'll start directly from Mr. Sekomoko Skeppers to ask from your point of view as a network, the network operator, how does the booming CNI market modify the electricity landscape and affect the management of networks? Which are the major steps that have been taken by ESCOM to face the complexity deriving from the CNI market? So,
all right. No, thank you very much, and good afternoon. Thank you so much for the opportunity. And perhaps to also reiterate Ronald's thanks to Rest for Africa for the support and the collaboration. If one looks at ESCOM from a historic point of view, and it's a pity my brother Monde has left, we have traditionally had a very close collaboration between ESCOM and the large industrial customer, the mining customers, and the commercial sector. And that is a relationship that we continue to nurture through the EIUG, through other platforms, where we collaborate because there is a great appreciation that we are interdependent and that we need to collaborate very closely together. If one looks at where we stand today, for example, with regard to load shedding, there's been quite intense engagements between ESCOM and industry around how you manage the available supply to meet the requirements and their contribution in a way that it minimizes the impact on their operations. clearly there is a lot of encouragement for industry to be more self-sufficient, largely through rooftop solar PVs, energy efficient initiatives and the like. And we have been very much encouraged by the progress because we are working closely together. From a system operator point of view, we have some products such as demand response that we are actually contracting with specific customers that when we have constraints that they actually need to reduce, and it's a controlled process. And I think that's one of the things that from a security of supply point of view is very critical, is that there should be proper coordination. The last thing we can afford is for things to be done in a disorderly manner, which can then have a very negative impact on security of supply. So the work that is happening in terms of demand response, solar PV, and other programs, I think has been well coordinated. Where we see potential shifts, which we still have to get the right instruments for, is really around rooftop solar PV. If one reflects over the last 3 months of this year, we've had periods when we've had a week of rain, cloud cover in Gauteng, and we see a difference of 1,000 to 1,500 megawatts of no generation, which the rest of the system must now make up for, which clearly is going to put pressure on the grid, it's going to put pressure on other generators to actually be able to compensate for that. So it has not been that significant that is a concern, but looking forward with the increasing incentives to get more going, it's an issue that we are looking carefully at to make sure that we can at all times manage supply and demand in a predictable way and in a way that is responsible and safe for the power system.
Okay, thank you. Louise, I want then to come to you because Sasol and Air Liquide have recently announced the realization of renewable projects to wheeling energy to their Secunda site facilities, and in partnership with a group of local and international IPPs. I wanted then to ask you your point of view about the process. I mean, first I want to ask you to provide us with more insights and also to explain which are the major benefits from this kind of approach that Sasol is putting in place in terms of decarbonization targets, of course, but also other possible, for instance, reliable and cost-effective electricity, but also in terms of the full strategy that you are pursuing through decarbonization. What is the perception about this process, and which are the major challenges that you, face during this process, or that you are facing?
Thanks, Mariana. I would like to start off by saying that just as early as last week, we reached financial close with one of our projects. Richard is sitting over there. Richard, maybe you could just wave to us. Msenge, which is near Bedford in the Eastern Cape. So Richard, as you all probably know, is the CEO of ACID, one of the partners to Sasol. This certainly has been an interesting process and journey for Sasol. It started about 2 years ago now. We obviously are a very energy-intensive user. And when we put out the RFPs, I don't think we knew exactly what to expect in terms of the responses that we would get. As you know, there have been 3, and we've been overwhelmed by the responses that we've received in the market to date. We've closed 540 megawatts approximately to date in terms of power purchase agreements. And many of you have been involved, have offered services, have been partnered to some of the projects that we have had in the market. With respect to how it's been going, I think, initially we thought it would be a fairly simple and easy process, and that hasn't necessarily been the case. We've had to partner with Eskom very closely, obviously, as the system operator. Ensuring grid access, of course, has been essential to success in this regard. And one of the big challenges, and you touched on challenges, has been the very varied definition of shovel-ready project. So everybody, unfortunately, Chris Yelland did me the favor of announcing my appointment before I actually started the job, and everybody suddenly got my cell phone number and was phoning me with their shovel-ready projects. And I can assure you that we don't have a uniform definition of shovel-ready in South Africa. So when it came to the BQs and the cost estimate letters, we had different understandings amongst the developers of what that means. You know, we had all manner of people telling us all manner of things. So that has been one of the challenges, and a standardized definition of shovel-ready. Also, as we know, as a sector, there are a limited number of advisors, bankers, lawyers in this sector. And so sometimes the Chinese walls get very thin, and that is not ideal when you're dealing with multiple IPPs and negotiating all at the same time. So I'll just stop there and give Mark a chance to maybe.
Yeah, Mark, if you can contribute your point of view in terms of course, we are board member representatives, but also developer in the sector. So I wanted to get your point of view in terms of the main difference and the main challenges from your point of view to deal on the same time with the private PPAs and the public purchasing process. So.
Thanks, Mariana. So Louise raises two good points. The time it's taken from the RFP to now, and obviously well done to Richard, James, and ACID for closing. But if that's a 2-year period from the RFP, the question is, I think Frank said it earlier, hopefully tongue in cheek, we should get rid of REAP and just do private. If it's going to take 2 years to get to where you have a signed PPA, where theoretically in REAP it can take 6 months, it's not the time to get rid of REAP and go private. We have to work out how both of these coexist. So the other good point you make is, what is shovel-ready? And that's what everyone's grappling with right now. So Eskom's grappling with, they've given out, they had these CLs. CLs have now progressed to the budget quote phase. They don't have budget quotes. And it's this 14 gig number. It's huge. But as Louise and Cecil worked out, they're not all shovel-ready. So from an industry perspective, what SAWIA has been doing, SAWIA and SAPFIA together, we've been working very closely with Eskom on the grid access rules to try and establish what are the measures that Eskom should put in place to ensure that you do get proper shovel-ready projects, and only those projects are the ones you're giving a grid allocation to. And the second main point that we've been discussing with Eskom is that the concept of a queue doesn't work. So Fabio showed it in his slide earlier of, is it best to have 100% PV, 100% wind, or should we blend them? If you're going to blend them, then a queue doesn't work, because if it's first come, first ready, it could be 20 wind projects, and then we've got no PV, or it's 20 PV. So we've been working very closely with Eskom over the last 3 weeks to discuss the rules. But the key things for industry is that it's not CNI versus REAP. We need some very transparent rules. We need a brutal assessment now of, as Louise says, are you shovel-ready or not? That brutal assessment needs to happen, that we free up capacity, that we can add more capacity to our really strained grid.
Okay, thank you. Sekomoko, before you go, I wanted to get your, your point of view on this topic of the queuing mechanism. If you have any insight that you want to share in terms of the kind of approach that you are following, what do you think about what Mark said? And
Yeah.
generally speaking, if you want to share anything on this.
Indeed, very, very briefly. I think Mark is correct. There's a lot of collaboration between ESCOM and the various associations. And I think it came up in the earlier session that with the lifting of the 100 megawatts, the rules changed, but we did not think ahead as to what they could mean, and therefore we ended up with a bit of disappointment for the REAP program. So there's been a lot of focus around the rules or the criteria, I think, which is more around the queuing, as we had called it. But we are having other debates, which is really to say we really need to look at the overall process. And I think that's the point you are making, that if we simply say what's shovel ready, it is good to know that has to be well defined, but in itself is not sufficient to help us from a grid point of view. And to also ensure that we, again, avoid more disappointments going forward. So there's more work that we have to do, more discussion that must happen between the stakeholders, so that we can move with a bit more confidence. The point that also came up in the morning, we support fully, which is really to say, ideally, the grid should be there before the power plants. Because we have a much longer lead time. You can set up a solar PV in 18, 30 months. Any line will take you a number of years. And that's something we have to actually turn upside down. And hence our appreciation of this research work that helps to point us to where we should actually be channeling the investment in the grid. Fortunately, I think there's a lot of appreciation now to say we need to invest in the grid. I think 3 years back, everybody was more concerned about let's invest in generation. I think that the penny has dropped, that there's an appreciation that we need to invest in the networks. What needs to be understood now is we need to invest strategically and proactively. We should not be waiting for applications. The resource is there. We know where it is. We should be designing the network and developing it proactively to ensure that we can then be able to connect on a timely basis. So I think what we appreciate is really the collaboration, because we are in this together, and we have to find solutions that will give the country the maximum benefit, not just to get out of the crisis, but also to ensure that we can sustain the energy transition that the country has committed to. And we appreciate work for associations such as MAC and the other stakeholders that also play a key role. But yeah, it is going to be difficult when you have to say to somebody, your project doesn't qualify. Not that it can't, but it is not ready now. So let's give the space to those that are ready so that we can be able to move steadily forward. And lastly, I think one of the issues that I think is also not always appreciated is that it's at the system level that you can see the cumulative effect of the different dynamics in the system. At an individual plant level, you may think I'm okay, but between your plant and the hundreds others that are there, at the system level, it may reflect something different. So there's more engagements that need to be done. So, for example, I mean, we're in Cape Town, and Cape Town is looking to do more solar and so on. From a system point of view, you say, but actually, this is not a good thing, because you are just adding more generation that is going to just lead into more constraints for the export. So it is good for Cape Town. It's not good for the system. And I'm sure the Premier will not be happy to hear me say that. But those are the challenges that we actually need to say, let's grapple and say, how do we make these things work in a manner that we don't compromise security of supply? Because that's really the goal that we have to get right. Thanks, Marianne.
No, thank you. This leads us to another important point, probably, because when we consider the integration of CNI projects into the grid, we have also to consider probably the social, consequences in terms of which kind of differences this new structure of the market can introduce, and which kind of difficult approach for you as a network operator to manage all these, once again, richness, but from the other point of view, these differences in the market in different parts of the country. So if you can share something on this also.
Yeah, I suppose somebody said it earlier that we are suffering from the Chinese curse of living in exciting, interesting times. The benefit we have, I think, is that we are not the first. So there are countries, TSOs, that are dealing with far higher levels of penetrations of renewables than we are. And we have a lot of good relationships through different platforms to actually learn and import that learning and, in fact, accelerate our own ability. So I think that is part of what gives me comfort that at the international level, whether it is SIGRE, Geo15, IRENA, we are very well networked with others that are far more advanced, and we can actually import that learning and ensure that we can catch up or even leapfrog, as the terminology says. We have had fairly basic, I think, tools to monitor the system, transfer limits, and so on. But we recognize that there's a need for more sophistication, more smarter instruments to help us understand the dynamics and what is happening, and to then be able to proactively manage the supply and demand. We've had, I think, for example, one instance in the last year of having to curtail solar PV because there was just too much generation in the middle of the day. So that intelligence systems are there. I don't think they are as advanced as I think we're going to need. And that is one of the areas where we will be needing to invest more effort to make sure the system operator, that the guys in the controls rooms have the right tools, and that contractually we are able to deal with the impacts of the new dynamic that will be playing out.
Okay, thank you very much. Now, Marcelo, speaking about expertise and experience in managing distribution networks, you can bring a lot of experience from your side.
First of all,
the ritual. Okay. Done. So
second, I need to fix XCOM because it has a little, the direction of the name is like here. I'm fixing XCOM for a while. Huh?
Oh, you're fixing XCOM?
I fixed XCOM.
You are so helpful, Marcelo.
And third, I will appreciate it. We are more or less 70 people now. I was little hearing you for sure, Mark, but 70 people here. I was in Johannesburg last year, and there was 10 people at this time. I was at this time, 10 people, you are better than other 70. Then it's a pleasure to me to be here today. Let me explain two things, first of all. When I was living in Chile, this is 25 years ago, we have load shedding there 1 year, 2 hours a day, no? And there was a baby boom. We were the double of baby boom. Then when you have the cost, the trillions of trillions, remember also you have the benefits of the children that is coming to life. And it was a blessed people, we double the load shedding of babies. That's good. Second, I know, excuse me with that. No. The colors of my friend of the chassis, where is the chassis? He goes, no? The chassis, over there. He collect the bill from reservoir and escape. No, the colors, you miss also the bureaucracy here. And you have the wind, yes, you have the solar, and you need to map the bureaucracy inside South Africa. No, this is to construct, and that's the finally. My friends, excuse me, I want to move my people. I want to disagree with Mark. Always try to understand what we can do. But let me introduce in 1 minute what we are. We every day, as grids, we distribute energy to 200 million people. Huh? I was discussing with you, no? Every day, we serve 200 million people in distribution. Then we suffer a lot in this distribution because we need to make investment, we need to propose things to the governors. But when the governors don't feel comfortable, they really push us to also to take out the concessions. Huh? So when you don't do very well your concessionary distribution, you are obviously you are a concessionary. And the concession is the government finally, you know? The responsibility from the government. Then when you are not doing well, they cannot take you out. This is when we feel very responsible every day to serve these 200 million people. There is another point. Today we have more or less 60 petabytes of information per year. Maybe you can say 60 petabytes is a lot, no? A lot of information that we cover with our Internet of Things, our smart meterings.
Do you need Sekomotso to fix
No, it's okay, no? You can fix
sure.
it. Yeah, please.
Sekomotso, it looks like you need some help.
Then we collect every year 60 petabytes. Maybe you can calculate a lot of information. And that allows us to a lot of things. For example, we reduce the cost of our operation 40%. That was 15 years ago. And we today save more or less 400 million euros per year in OPEX in Italy. 400 million euros in Italy. Then, this is more or less 25% of the CAPEX. This is the fair equation. So ESCOM, not you also, all ESCOM, needs to analyze how to be efficient to reduce 25% of the CAPEX in OPEX, understood, the TOTEX finally. And then you can apply this to increment the investment to make more reliable. Because we also improve the quality 80% with these devices, the intelligent devices like the automation, like the self-healing, and like the smart meters. No? Then my proposal to ESCOM, and I was hearing this day, for sure, you need to cap the tariff, you need to introduce efficiency, then you have a space to go to more CAPEX, and it's possible. And we can share with you that the opportunity how to do it also in countries like Brazil. That is very similar to the South African, I would say, reality. That's a very good country. Then less cost means more investment and more quality. You are forgetting something, may I say. You are really strong now in the discussion about load shedding, but you are not seeing what is coming. And what is coming, you need to solve very soon also the quality perceived by the customer outside of the load shedding. So you need to solve only maybe 10 or 15 hours per day, and you're going to suffer the day after. No, this is funny. No, you need to solve the day after, and how you can solve that when the energy transition is coming. Then there's a lot of issues to discuss, and this is my proposal to my friends, no? How to challenge this with the tariff, with the government, the concessionary responsibility, with the increment of the cost, with the OPEX reduction, with the quality. Everything needs to be very, very strong solved. And we can help because we suffer in the last 40 years a lot. We are not really brilliant. We are only more old, maybe, in the decisions. And that decision, we can help all my friends to do good things. We propose to work together always.
Okay, Marcelo, in terms of digitalization, for network operators and end users, which are the main benefits that can come from this?
Perfect. I would say, for example, in our country, in Italy, when you do not pay the bill, they reduce 90% of the power, no? So you will never be cut of the energy. When you don't pay, it will be delayed, no? And in that case, everybody pays the day after. This is the first issue. You are not allowed to cut the people because it's a sensible social issue. Then we reduce. But when you reduce, the reaction of the people is immediately, you need to pay. Then collection goes to high, 90%, 99%. This is the first. The second, the losses. When we put the device, Internet of Things, you censor the people who are stealing the energy. You find a transformer, the first meter, no? And you have 100 people. And you make instantaneous balance with the people who are taking the energy. You go send your people there and catch who is stealing. Then losses less. This is billions, billions. The third, for sure, is the efficiency on the operation. You don't need to go. You can change your provider. You can change the commercializator in 6 hours. They change that, and you can move from better tariff. The fifth is the energy in the car. I have an hybrid car. This is a Mercedes with 100 kilometers of autonomy, but it has 700 of diesel, but 100 of autonomy. Why I bought that? Because in the night you can charge in your house with your car of 100. You cannot charge more because you need to change everything. Then 100, in the night we have the half of the tariff. Then you can save maybe 90% of the diesel comparison. Then you have net tariff with a lot of efficiency. The last one, may I say, is when you have this type of information, you can also planning. And I'm going to go to the final point, that is the virtual. Remember, the virtual grid futurability. We have also all the digital simulation of the network. When I can consider, if you have a body now, no? I can make you a scanner. I can simulate your mark like another person that is digitally, and we can run there a cancer. We can run there a disease. We can run and we do that with the networks. We program the planification of the network with the digital twin. We have a digital in all the substation and in all the lines. Understood, no? We can simulate everything. We reduce again the case. Go to the numbers, because my friends want the numbers always. We reduce in the last 12 months 30% of the cost of cut trimming. You have a lot of cut trimming, I'm sure, with these digital twins. We can share with you maybe that type of software. Then everything is good. But everything is good not because it's because you need to reduce the tariff to introduce new investment. Understood, no? This is what ESCO needs to say. Okay, let's solve this. But now we need to improve the quality and the service. But how can I do without increment the tariff? You need to treat more efficiency. That is digital. Then the digital transformation is really a reality. Then you can do it without impact the people.
Thank you. Thank you very much. I wanted to come back to you, Luisa, in terms of Siena market, to ask you, based on your experience, what are the opportunities that you think smaller CNI customer can have to penetrate the market? Meaning, is this segment to remain just a niche for big players, or which is your view about the development of this segment?
Thank you. I think, if you look at our programs that we have undertaken, there's a mix of the large companies, some of whom are international, some of whom are local, and then we also have local players who have been engaged, either individually or through partnership arrangements. One of the I guess it's both a blessing and a curse to be the first one to do these things, because you are setting the rules and the way in which things are perceived to be done. But then also it gives us the benefit with hindsight to look at how we've undertaken these projects and to then modify our behavior accordingly. So whereas, most of our projects to date that have reached legal close have been with large players, I think we are very cognizant of where we live, the environment we operate in, and what we would like to do in terms of being responsible citizens in South Africa as well. So I think that very much would set the tone for how we will adapt our behavior moving forward. Having said that, we are undertaking a thorough review of everything that we've done as Sasol to make sure that moving forward we are doing things in an appropriate way. So that's where we are now at the moment.
Can I ask Louise a question, please? So one of the barriers to a rapid uptake in CNI in South Africa is that there's no standard project docs at the moment. You've gone through this process. Do you think we are far off getting close to? I know all big corporates are going to want to tweak it, but are we far off getting close to standardized, or do you think you've done it when Anglo does it, when Glencore or whomever does it? Are they all going to want to reinvent, or are we going to get there, and if so, how quickly?
So you should have come to my panel at Solar Power Africa, where we spoke about standardized PPAs. However, having said that, you clearly missed it. So
you didn't invite me.
Organized by Sapphire.
I'm Suia.
Yeah. Insofar as is possible, we have attempted to look at standardization of documents because of exactly some of the things that we've experienced through this first round. And when I say first round, there were three RFPs that went out. So we have attempted to do that. Also because, again, and I think this has been a criticism of REAP, that a lot of people make a lot of money, and those are often lawyers and bankers. And so we have looked at trying to reach standardization of the documentation, but it's not always possible. It's just not practical. And especially in this first round, I think we've gotten better at it. We are not perfect yet.
So final, has ACID got better terms than Enel?
Wow. So the moderator, it's me. So now we are going to say thank you to Mr. Secomoco Skeppers because he has to leave for his flight. And thank you again for participating to the discussion.
You fixed
it is fixed.
Okay, thank you.
Yes, we appreciate the help. Please do forgive me. I have a flight to catch. It's a pity I couldn't stay a bit longer, but very interesting discussions. Much appreciated.
Thank you.
Thank you.
Thank you. So let's open up for questions. Please feel free to participate to this discussion.
They want the coffee.
No questions.
No questions, really?
Can I ask Marcelo a question?
You want to? Okay.
Not to fight yet. Just to ask you a question.
Yeah.
So when you speak about distribution, what do you? Because ESCOM has their definition is 132 kV above transmission.
Yeah.
And then below is distribution. Does that the same for you, or are you just talking about?
Yes, exactly. We were obliged to sell all the high voltage line transmission in all the countries due to unbundling issues and to anti-monopolic horizontal integration. No? Then we call distribution is from 220 in the substation of the city. Mm-hmm. We have high voltage, medium, low. And this is our perimeter, up to high voltage of the distribution of the asset of the distribution city. Huh? Then the long lines are more transmission. We are not there. We are not allowed to buy that. Or we are allowed, in some countries, only 8% of the asset. But this is not the way. We call, do you have a doubt on that, or you want
No.
Want to discuss?
It was a leading question into the next one.
Yeah.
So ESCOM's issue is transmission right now.
Yeah.
Whenever you talk about private sector doing it, the understanding, which is logical, is that transmission must be left to the
third party. Yeah.
Well, it should be left to government to do, and maybe distribution you could look at differently. But in a crisis where we don't have the transmission, what would your view be in how the private sector could alleviate a transmission crisis?
It's a very good question. I was not prepared, really. Because I was thinking in distribution. You cannot believe how the infrastructure funds, BlackRock, the big ones, are investing in transmission when the rules are clear. Then there's a lot of good payments in the M&A transaction in all the world from asset of transmission when they are very clear in the revenue very clear, WACC and OPEX recognition, then they solve immediately through the stability. So today in the world, it's more interesting for an infrastructure fund or of a bank is a transmission than because this is the way to solve this, to separate. And the government could keep that, maybe 49, 51, but you have a very rule, unbundling without the cost of the government inside, using an independent company, you have a lot of interest there. This is the way to solution. In distribution, there's a lot of models. A lot of that's private, could be remain state-owned, but in that case, they will be remain inefficient, need to collaborate in a stewardship model, maybe when I like a private. So you can have steward, private owner, but it's important to introduce efficiency. This is the key point. If not, you need to change the organization, you need to change the system, etc. Then to solve, to separate for sure. If not, you are going to have a chaos inside every stage of the chain of the value, and the responsibility also is not clear between all of these components. Then this will be my suggestion. It's operating in all the world. But again, the transmission is more appetized for that than the distribution, and distribution is very good. We need to separate a little. Mm-hmm. I answer your question. You're a little tired after the bicycle years. Yesterday you were like this, and
I'm a little bit tired.
Yeah, are you sure?
Sorry, yeah. I'm not as sharp as I should be.
Okay, and you make how many kilometers yesterday?
108, I think.
108.
Yeah.
In
I
taxi,
did more because I had my son behind me in a tandem, so I probably did 208.
Wow. Okay. So, a question.
Okay, thank you very much. I'm Lucy Mario from Professor Consultancy. Based on a gentleman, sorry, I forgot the name. No, the other one.
Yeah, he is the gentleman. I'm right.
He's the bicycle.
Marcelo.
Okay, so based on your input, I really appreciate the fact that there is a great technology that actually is being used in Italy to control energy distribution. Where now I can't really see that in the fact that, let's put it from the perspective of an urbanized area, like South Africa. There's great areas that are not urbanized, and it's difficult to actually implement such kind of technology to control energy distribution. So now, what would be the best way? Because I know that you're speaking from the Italian perspective, but now let's look at South African perspective. What would be the best way to implement such kind of technology in places where there is no urbanization?
There's a lot of scenarios. Huh? Let me be very open. I'm not going to guide the government for sure. I need to be open. The more important is the stability. For example, I saw a model in the past. I cannot say the country, but they say, let's fix a tariff for 10 years. Okay, fixed tariff. Let's give to the private to invest, and every difference between the fixed tariff, the rules, they can invest more. Then they want a lot of money maintaining and replaying all this in the profit sharing scheme. Then you can fix the tariff and give to the private sector, yeah, the possibility to invest. But you need to have fixed for 10 years. You cannot change the rules. This is one. The stability on the rules, I will appreciate 10 years. There is another issue. You can combine private partnership with the government. Huh? Public, we say, partnership, that is good because you can operate as a private and they own as a state-owned company. So you cannot sell, you don't need to sell to say ESCOM now is private. But no, you can also maintain the property, but you need people who experience the private public operation. This is the second. The third could be that you can separate operations, no? Some countries say 1/3, 1/3, 1/3. The north is from a private, no? The center will remain ESCOM. There's some issue that conduct, but this is more sensible from the, political side. You need to be comfortable on that. But it's my understood, no? The fifth could be you can, in the high voltage, because you need a lot of needs for sure in the high voltage in distribution, no? To get the security of the area, no? You can make a company also only for the high voltage transmission and distribution and make a joint with a public-private company, no? And invest there with a special rules again. Because when you say, understood, when you give really 10 years of fixed rules, fixed WACC, fixed open rules, fixed tariffs, whatever, a lot of money is coming. When you, every 2 years, the government change the rule, everybody escapes. This, 10 years is a scope, this is a solution.
Okay.
You agree, no?
Yeah. Another question.
Yeah.
Of course.
You agree, no? Yeah.
Marcelo, I've got another question. Sorry, it's Simon from the Solar Group. I think you've heard a lot today about this grid congestion, and Mark also mentioned this conflict actually that's now arising between the state procurement and the private sector. And that conflict, I just would like to understand how this works in other countries in Italy and in Europe in terms of the grid availability and how these queuing systems or prioritizations of the applicants work in Italy. Obviously here in South Africa, as you can hear, there's been these long delays in terms of government procurement program, and now we're hearing also on the private sector side some sort of option buying for the grid connection network. And obviously what we want to do is the fairest, quickest way to allow projects which are viable and shovel-ready to connect. So I just wanted to get some insights in maybe in Italy and Europe, what they've done there to resolve that, if at all.
Okay, there are only few companies and a state that remains, like France, for example, remains as a public distribution operation. I don't think they are going to be the best in efficiency. Huh? Then almost all Europe are privatized, and they are trying to do it at the best way. Huh? This is second. But I believe more in a transitional period that could be a private-public association. If we can discuss with ESCOM, for example, to have a private-public discussion moving together, then they need to see what is happening, what is the level of inefficient, level of digitalization, level of energy transition, level of quality do they have. You need to be sincere with yourself, with a partner, and say, oh, we need to set up this. Then the first of all is to see and hear, no? When you are totally public, you cannot see so much. Then it's better to the public-private association. This is my recommendation. Not always private is one of the best. We analyze a lot of operations in Australia, a lot, And the cost of operation in Australia is close to here, no? You can go in a bicycle, you can go in a boat to Australia, no?
Quite far.
Yeah, could be. The cost of operations in Australia is 5 times Italy, and they are private. The Chinese are there, you know that, funds, and they're 5 times the cost of Italy, Europe. Then why? I'm going to say you why. Because there was a private, then private don't miss efficient. That's why I'm trying to argue to you. They have a very good, but they don't have profit sharing. Profit sharing in regulation is, if I reduce $1 as a good operator, 50% for the tariff, 50% for the investor. Then in Europe, everybody do like that. Look like a triangle like this, because everybody wants to take a piece on the efficiency. In Australia, it's not possible. They have clawback. Then who cares about when you have clawback on the efficiency? Nobody. Then it's only profit plus good regulation, okay? Plus good technology. Then a lot of things more. But in a few words, I think private is the way. If you are not ready, it's a public-private for the initial with a good faith collaboration.
So just to add to Simon's question, so if you had 4 project developers who now want to access your network in Italy, what is the process of giving them a firm allocation, a firm network allocation that they know that they can connect? Is it a first come, first serve? Are projects assessed on a regular basis to get that actual grid allocation?
Okay, more or less, we connect in our networks 5 giga per year of producers, no? We have today in Italy 1.2 million of prosumers, a lot. And we really have a lot of savings, what we discussed with Chess, you know? With people are really helping the development and the planning. Huh? More or less the double of the requirements are abandoned. So we need to fix all, look for the real interest on the double, and they only half are real projects, always again. And it's for sure, it's first come, of the serve, but you need to remain in the request. Now, with the actual war, there are a lot of new special commitment from all the governments to connect in very few months. No? In fact, we are constructing a plant, as you know, maybe, we are constructing a plant in the south of Italy that is going to produce 4 giga per year in a photovoltaic Enel. Then everything is now going on. We have a factory, and all the permits are very fast, like less than 1 year. No? That's it. There's a lot of movement. Huh? And I propose to you to Mark, if we have another call together, we can expose to you and you also to what is the time, and we can compare with Africa. No? But everything is moving very fast because we need it. We don't have gas. We don't have generation. We have a load shedding like you, but without gas. A gas shedding. Huh?
Thank you very much.
Thank you.
To all of you, and I will ask you if you want to share with us any final remarks. Otherwise, we can close here. Mark,
what wine are you serving?
Actually, I don't know. So let's go to have a glass of wine. Luis, do we want to share any final thought?
Thank you.
Okay, thank you very much.
Thanks to you.
Please, a round of applause for them. Thank you. Okay.
Thank you, Mark. Thank you.
So it's time to close the discussion today. So I want to thank you, all of you, for your attention, for being here, even if we ran late, a little bit late. But now we can enjoy the networking cocktails. So I hope you will have the occasion to engage more. And yeah, as Rest for Africa, I mean, we learned a lot today, and we hope this was insightful for all of you. We want to express my appreciation to Netbank first for the opportunity for hosting us in this wonderful venue today. And yes, once again, to all of you. And I want to encourage everyone to share, ideas and every kind of suggestions for us to going forward with our program in South Africa. So as Roberto explained this morning, we are active on supporting with technical research, with I mean, this kind of dialogues as we had today, and also capacity building. So the idea is to have something similar to what we run every year in Italy, that we call is our flagship program, high-level program for policymakers, run in cooperation with the Bocconi University and Polytechnic of Milan. The idea is to run something specific for South Africa here on the ground, but any kind of suggestion, input from you, it's really valuable for us to, I mean, enrich our program and to go forward by highlighting the right topic, the right angles that we have to look at to be, I mean, to bring a contribution, a real contribution to South Africa and to the South African electricity market evolution. Thank you again, and have a good, I mean, let's see at the networking cocktail. Thank you very much.